Okay, this is the video for Thursday this week. It's on 1.6 continuation, and that'll be homework that you're going to have next week. What we're going to do is we're talking about this thing called a limit. And the limit's really, really important because remember the big picture here? We're trying to figure out how fast something is moving at a moment in time, or how fast the chemical reaction is taking away at a moment in time, or how fast the stock market is moving in a moment in time. And we know to find the velocity or the rate, average is distance divided by time. But if you want to do it at a moment, we have to let time go to zero, right? And you can't divide by zero, because distance divided by zero would be, So what Newton and Leibniz came up with the idea called a limit. What we're going to ask ourselves, and we did a type of questions that you had for homework this week, but the idea is to continue in different formats. What we want to ask ourselves is what's happening as I get really close to a point. Not what's happening at that point. That's the thing you have to go, no, that's different. That's different. It's not what's happening at the point. That's called the function value, right? That's what we've done in all algebra. You put 2 in, you get an answer out, or whatever, right? Well, the question is, what's happening when I get really close to 2, but I'm not actually 2? Okay? Now, it turns out that normally, those are the same thing. You get close and close to the point, you eventually get to the point, right? But in calculus, you don't, right? You get this 0 over 0 idea all the time. So let's look at it visually. So here's this graph, okay? I got this graph here, it goes to the point, 0, 1, it goes up here, and then all of a sudden it breaks down here, and then it goes like here, and so it's all broken up. Now, the first thing we're going to do is we're going to say the function is discontinuous at 1 because it's broken. It's discontinuous at 2 because there's a hole in the graph. Now, keep in mind, let me just erase these for a second. It's just that it's not there at a point. The way and you've seen this before in math, the way we signify that it gets really close to that 2 and it's open there is we put an open circle. Okay, so just be aware that what that means is it's not, there's no actual value at that open circle. So what we're going to do is we're going to ask ourselves, what is what's called the limit? Now, what we're going to do is we're going to talk about limit from the left, which we're going to put a little minus sign. It would be really nice if we put a little L, but they don't. They put like a minus sign, which is a little misleading, okay? That means if my nose is like the point we're trying to go to, you've got one on this side, one on that side. If you're on the left side, we're going to say that's this is numbers like 0.99, okay? 0.9999. Or this is numbers like 1.99, or like 2.99, okay? And that's a little oversimplification, but that's the idea. Getting really, 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 really close to 1, but I'm always less than 1. That's what this minus sign means. Now, if there's a plus sign on it, that means I'm getting really, 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 really close to that number, but I'm always bigger than that number. So this is like 1.01, this is like 2.01, 3.01. Now that's not, that's a bit of an exaggeration there because we're actually getting infinitely close. We're not going to be 1/100th. We're going to be infinitely close. But just to get the idea, okay, that I'm getting really close. So how do you do this? Well, at 1, if I'm on this side of 1, notice that I'm getting closer and closer and closer to 3. I never get to 3. There's no function value. In other words, when I put 1 in, I don't get that. It's filled in at 2. So the function value here is 2. That's not what we're talking about. That's algebra. Okay. That's not what we're dealing with here. The function value is 2. I get that, but that's not what we want. What we're going to say is the limit is 3. What happens if I get really close to 1, but I'm on the other side, like here, like 1.1 up here? Notice as I get closer and closer and closer, as the x values get closer and closer and closer to 1, the y values are going to get closer and closer to 2. So the limit does equal the function value, and that happens a lot. As a matter of fact, it happens every other place except when it's broken, right? In other words, if I were to try to look at limits anywhere except these 3 broken parts, the limit would be the same as the function value. It would be uninteresting. Okay, so now here's the rule. you don't look at the limit as one by itself in these type of questions. What you're asking yourself is the left the same as the right? No, sad face. So that means the limit does not exist. The limit does not exist, okay? Because the limit from the left doesn't equal the limit from the right. Now, there's a lot of forms of non-existence in math, okay? So that's kind of just a broad stroke one. If the left and the right are not going to the same point, they're going different places, like in this case, one's going to 3, one's going to 2, the limit does not exist, okay? 1.99. So if I'm really close to 1.99, I go up here, and the closer I were to get to 2 from like 1.99, the closer I'm going to get to 1. So remember, f is for the y value. Notice what we're finding here is what are the y values getting really close to? Okay. Okay. 2 from so if I'm on 2 on this side, and I get closer and closer. Oh, I'm getting closer and closer to 1 again. Hey, these are the same. Hey, happy face. Well, I don't know what's happy or sad, but we're going to associate sad with being not the same and happy with being the same. I don't know why. Just why not? So then we say the limit is 1. Now, here's the thing. The limit is 1. The function value is actually 3. If we actually were to actually put 2 in, out of the function box would come 3, right? Back from algebra, right? Again, this is not what we're concerned about. We're concerned about this thing called a limit. And that's going to be really important to realize it's getting really, as I get really, as x, it's not I, as the x values get closer and closer to 2, the y value is getting closer and closer to 1. The funny part is if I actually get to 2, I pop up the 3 according to the graph. Okay, how about 3? Okay, so if I get really close to the number, remember from the left is like numbers like 2.99, I go up here, and you can see I'm getting really close to 2. And then on the other side, if I pick a number really close to 3 on the x line, if I go up here, it's just going to get back to a number that's really close to 2. Oh, these are the same. Happy face, happy face, happy face. Okay, so that's 2. Now, what would the function value, though, at 3 be? Be undefined. Now, I'm going to talk about something now that doesn't make a big deal to me, and I wouldn't think anyone thinks it's a big deal, but vocabulary. If the limit is bad, if there's no limit, we say the limit does not exist. If there's no function value, we say the function is undefined. Don't worry, if you ever use undefined instead of does not exist, I'm not going to mark you wrong, okay? It doesn't matter to me at all. Okay, so that's that one idea. Now, the next idea is on vertical and horizontal asymptotes. 2 different ideas. They have very similar vocabulary. That funny word, asymptote, whatever that means. We have to know what that means, actually. But anyway, so the vertical asymptote and the horizontal asymptote, okay? Now, let me go back and graph this real quick. Don't panic if you can't graph this right away, okay? Don't panic, okay? But the graphing will help me explain what's happening on. You can actually answer the questions without graphing, so don't panic here, okay? But it's going to help me explain it. So what I'm going to do here is you're going to factor this. X plus 3, x plus 4, and then this one's x plus 3, x minus 4. Oh crap, this is a bad question. Hold on, I gotta fix it. I'm gonna make this 6. You guys, change that to a 6. My bad. Okay, x minus 2. Okay, so the top one factors into these 2, and the bottom one factors into these 2. Okay? Make sure you change that to a 6. Now, what you can then do is you can cancel and you get x plus 4 over x minus 2. Now, you may remember how to do this, you may already know how to do this, but don't panic if you don't. Remember how you do this. You're going to get what's called a vertical asymptote at 2. Because that would mean when you'd be dividing by 0. To find the horizontal asymptote, now this may be something you don't know, it's not hard, but you say to yourself, what happens if I go to infinity? Like, I use the word I again, that's silly. When x is a big number. If x is a billion, and I take a billion plus 4 and a billion minus 2, well, it's basically a billion divided by a billion, right? If I head out to infinity, that stupid 4 and the stupid 2 don't matter none, right? If I'm like Bill Gates and someone gave me $4, what do I care? If I lost $2, what would I care, right? So that's going to be 1. So we have what's called the vertical and horizontal asymptote. Now, if I actually put 0 here, if I put 0 in for x, I'm going to get -2. And if I put -4 in, I'm going to get 0. So that's just putting 0 in for x, and then what will make it 0 is -4. And then you just connect the graph, right? Now, again, don't panic if you can't graph, okay? That's that graph. Now, I need to be real clear. Here's the point. Here's like the whole point. It's kind of silly, but no, it's not silly. But it may seem silly, but it's not. That's the graph to this here, okay? But if I try to put -3 into here, I'm going to get 0 over 0. So at -3, if I put -3 in, there's got to be an open dot there. So this green graph, okay, so just make sure you got this. The red graph was that blue function. The green graph with this little hole in it, which is kind of what we discovered in the last homework assignment, is when you get the 0 over 0 thingy, is that. So are the blue graph the same as the black graph? No, they're totally different. Well, totally. That one has an open hole that the red one didn't. Okay. Now, how do you do vertical asymptotes? Vertical asymptotes is when you divide by 0. Oh, you know what? I feel like getting black pen out now. Vertical asymptote is when you are dividing by 0. You're dividing by 0. When you're dividing by 0, at 2 and -3, but here's the weird part. We don't count the -3 because it's a 0 over 0. We'll notice that we're not going off to infinity there. So you only have one, even though how they'll ask us on the AP exam is they will have multiple choice. And one of them will be, say, 2 and -3. And a lot of people put the -3 because you think you can divide by 0, it's going to cause a vertical asymptote. Not always. Not always, right? It only causes a vertical asymptote if it's not 0 over 0. So this one, even though we're dividing by 0, it's not just about dividing by 0. It's about dividing by 0 when the top isn't 0. So there's no vertical asymptote at -3, just at the 2. So the answer to the question is there's a vertical asymptote at x equals -2. Horizontal, of course, means going this way, and that's just this line here. Y equals 1. Now, what is that? That's not when you're dividing by 0. That's the limit when x goes to infinity of that function. In this case, when x is huge, I get something divided by 1. You can even do it here, but it's easier to do it when you simplify it. There's 1. So there's the vertical asymptote and there's the horizontal asymptote. Okay, this is another lecture on 1.6. Thank you. Oh man, I'm still wearing this thing.